Hello everyone. How are we doing today?
Good, 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 good.
Yeah, nice. So, it seems that it's only us today. So let's go right into it because there is one particular chapter that I thought it was really nice. I guess you know which one it is, right?
If I have to guess, that will
If you
be.
have to guess,
Give me just a second because I closed the book. Don't it knock that error?
almost. I would say that my second one,
And then the other one,
the one that we speak every week, every week,
don't
every
repeat
week.
yourself. Yeah,
Yes, don't
it's the
repeat
one.
yourself. So hopefully, when you read this chapter, you guys said like
Yeah, that's Umberto.
like
Yeah.
hopefully, yeah, exactly, pretty much, pretty much.
Wh-
So yeah,
What I didn't know is that it's actually like a well documented principle. It's not like a word of mouth, like, oh, you should do this, this,
so
that, that. No, comes from a book, I don't know how long ago, The Pragmatic Programmer, that is actually quoted along the book many, many, many times. So maybe I
uh,
need to read that book.
yeah, it's a very good book. I think we could read it here. You don't have to do it. Yeah, it's a good book. But yes, of course, this is a concept. Okay, let's put it like this. It's a concept that has been around even before the book. I just think the book popularized it. The book, because this book is very, very, very popular, and probably it helped spread the word much more. And of course, I did read that book, and it is from here that at least um, I became aware of this idea, plus experience as well from previous jobs. But let's speak about it. Let's speak about it because um, it's a it's a very important concept. What would you say about it? I want to hear from you first. What would you say about it?
The I like how we break it off in
Hmm.
parts when he says like repetition in process calls for automation. So if I'm seeing myself doing something over and over and over and over again, maybe I can automate it somehow. And then he says repetition in logic calls for abstraction. That's extracting a function and stuff. So I like that, like
Yeah,
how you got
Eh,
distinction there.
yeah. In the course, we do mainly
Logic.
logic, correct. So we have a code, a piece of code, and we find ways of removing repetition or removing duplication. And many of the ones that he said here, or actually the two he said here, are the ones that we apply over and over and over again, which is if you find yourself copy and pasting, that is an indication, A, we should probably extract a function or do something to remove this. And the second one is in the if else in our case. So if you see that you have a bunch of branches and you're doing almost the same thing in all of the branches with minor adjustments, then that offers the opportunity for refactoring. And I have to say that Kotlin, Python unfortunately doesn't have this, but Kotlin has it really nice, this concept of if statements as an expression that allows you to do things that, for example, in Python is not possible. And in case you're wondering, the switch statement, we don't have that in actually none of your languages. We don't have that in Kotlin, but
That will be a
we have
when.
instead the when statement, correct? But the switch, it's something similar. Good. Yes, and of course, repetition in the process. I would say
Detect.
that is one. Another example would be a more common example. Let's say when it's time to. We're not gonna do that in the course, yeah, but it's a common example. You have an application. It could be a mobile app. It could be a web app. It could be any type of app. Whenever you want to release this, there's usually a set of process or a set of steps that you need to take, which are usually always the same. For example, you finished you say, okay, I'm ready to deploy. That's the appropriate. Ready to deploy to production. Common steps are, for example, you go ahead and you update the release version. Okay, now it's version 2.3 as an example. After you have done that, probably, depending on the company, but probably you create a tag on the commit history so that you know in this commit, is where this new version appeared. Then here it depends on how you deploy, but let's say that you were to deploy in the Google Play Store, yeah, in the Google Play Store, for example, then you need to kind of create an APK file, and then you need to upload that file. So, and always you do those steps. Yes, you can do them manually, but it's a pain having to do that. Instead, you create a script or something, which by the way already exists, so that you can automate this. You press a button and do, everything happens. And the beauty of that is two, actually three that I can think of. What do you think are the beauty of having an automated script, let's say, that once again automates all this processes? What do you think is the beauty of that?
The first that came to mind was consistency. That means that every release will
Consistency.
be consistent. So the
Exactly.
naming will
You
be consistent.
not
All the
only
tags
that,
will
but
be
not only that, but you're related to consistency, the aspect of you don't run the risk of having errors, because you know that the steps are going to be always the same in the same order. Once again, consistency. Exactly correct. That is one. What's the second thing?
efficiency, means that you don't have to do it manually, so it's faster.
Exactly. Not only that it could be faster, but let's put it like this. Imagine that every time you have to, imagine if every time you have to release, you have to do a dance, you have to do a bunch of stuff. What's going to happen? You're not going to be as motivated or as interested in doing the release, because you say, oh man, now I have to go through this stuff. I'll do it next week, for example, or let's wait until the next sprint to release. But if you have a process, or if you have automated this process, you can release every week if you want it. Every time you do stuff, you release. Exactly. So for example, to give you two examples, you guys don't probably notice it unless it's a bug, but the content in the LMS, I release almost every week. Many times you don't notice, but unless there's a bug, you tell me, hey, Humberto, this thing is not working, or Humberto, the instructions are not clear. Okay, then you see that I release. But otherwise, I'm releasing every week. I'm releasing new content for you guys, or I'm fixing stuff that probably I said, okay, after the lecture, I realized, okay, this was not very clear. Let's change it up a little bit. And again, because I have a process that I click and boom, the same thing for the plugin. Every time I need to do a release, in the beginning, I didn't have a script. It was a whole dance that I needed to do. One of the first things I said, okay, I need to create something that I just click a button and the thing actually deploys automatically. That is for that. But there's one more. There's one more. You already said two: efficiency, or at least like so that you don't, yeah, do it often. Consistency, to make sure you don't have errors and things like that. There's a third one. Probably this might be hard to come up with if you have not worked in the industry, but let's see. Any other thoughts? Maybe you can come up with another one. No? Okay. Let's say, hypothetically speaking, we're a team, and I am working on Android, and I am the one who knows how to deploy to the Google Play Store. And tomorrow I get sick, or tomorrow I decide to leave the company. Guess what's going to happen? If there was no one else that I trained or that was involved in the process, good luck then finding out how Humberto did it. I mean, depending on the complexity, there are certain things that you just find out. It might take a little bit more or a little bit less. But ideally, if you have a system like this, not only more than one person knows how to use that system, so that if that scenario happens, someone else can take over, but also if we don't have to go to the extreme. If for Humberto is on vacation for a month, at least, I mean, he's coming back, but at the very least, we can continue deploying. We don't have to wait for 1 month until he's back. Why? Because as long as there's no bug, I click the button and the thing should be as automatic as possible and the least amount of manual involvement. So that is the beauty of automation. And this is what I meant from a conversation we had in the past, that you said, Humberto, I don't know what ideas to come up with so that I can create something to automate a tedious task that you're doing. Create an app for something that you have to do all the time. It doesn't have to be beautiful. Just use it as a context for Yeah. Any questions, any thoughts about this? I think this is a beautiful chapter. I think this is a beautiful chapter because it doesn't only apply to programming, it applies to daily life as well. It applies to daily life. And I can recommend something as well. And this is a little parenthesis. This is not related to programming. It applies to programming, but can be applied to much more. We are all familiar with the concept of a to-do list. I'm pretty sure everyone has like, oh, I have my to-do list, and so on. And that's perfect, okay? Don't get me wrong. But there is another, you could say the cousin of the to-do list that plays a very important role. It of course depends on what you do, and that is a checklist. What do I mean? Let me give you an example. I have a bunch of checklists for stuff that whenever I need to do something, there's a series of steps that need to happen. So let me give you an example. Last week, we began a new education, new students. Every time new students, we start a new group, there's a series of stuff I need to do. Like for example, create their accounts in the LMS, create their accounts in the plugin, bunch of stuff that I need to do. If I try to rely on my memory, trust me, I'm gonna make a lot of mistakes. At the same time, if I want to bring someone on board, it's gonna be a problem because how do I tell this person what he or she needs to do? I mean, it will take a little bit of time. Before you are able to automate something, what is one requirement that you need to satisfy before you're able to automate something? You're muted, Enrique, you're muted.
You need to like fragment the stuff that you need to do into steps, like
exactly. Another way of saying that, before you automate the process, you need to understand the process. Because if you don't understand the process, how are you going to automate it? And one way that at least works for me, that helps me automate the process, is by creating, as an example, a checklist. When I have a checklist, I know, okay, these are the steps that I always need to take in order to do X. And once I realize, okay, these steps never change, then my next step is, okay, how can I automate this stuff? I haven't taken the time into automating the stuff because registering new students is not something that I do every week. I do it twice per year. I'm going to spend significantly more time trying to create a system to automate that stuff rather than just twice per year, just get 2 days out of 365. And that's it. I mean, you see? So anyways, but think about that. Think about your daily lives checklist. And by the way, there's a very good book that is called the Checklist Manifesto, which speaks about this even further. I can highly recommend it. Good, but very good. This is another one that is related to this. Don't rely on magic happens here. Who would like to share something about that chapter? Don't rely on magic.
That was a good one because it's not only for programming; it applies for everything. Whenever you're working on a place and that is fragmented in stations, sections, and stuff, you always assume that the other section, I don't know what happens there. It's just magic. I'm just counting that it will happen, and I don't know how it happens. I don't know how it should happen. I just know it's happened. But
exactly.
I'm always was the kind of guy who try to understand how the other stations work, because if the stations are interconnected, the better I know their process, I can adjust my process to fit everything. So
exactly. I mean, I would say that I like what you said of interconnected because, for example, hypothetically speaking, let's say that you have an Android app, you have a web app, and you have backend. If there's no relationship connection between the front end, like the web and the Android, to be honest, I'm not that interested into web. So you might not see me on the web related discussions, especially because the web system has no effect on the Android system. I'm not that interested. I was never interested. However, and again, because not and the Android doesn't depend on the back end, the web in any way. However, the Android depends on the backend. Even though I might not, let's say, I would not like to become a pure backend developer, just because the app, what I work on, depends on this backend system. It is on my best interest to at least become a bit familiarized with what's happening in there. Not necessarily because I'm interested in developing software there, but as you said, since my system depends on that system, at the very least, I need to know what's happening. Yeah, and companies usually they have their, let's say, their GitHub account, and you have all the repositories, and you can see, hey, let's see what are people doing there. For example, what are people doing there? And so, yeah, it is important because if one day, say, the backend goes down or something happens, ideally you will be in a good position to determine, hey, probably it might be here, or you'll be able to have better conversations. But if you just close your eyes, I don't care what they do over there, your system depends on it. So again, you don't have to be an expert on it. That's why they have their own team. But at the very least, you need to understand what's going on there, and yeah, how at least certain parts, um, um, how they affect you in your system, because your app does depend on that. Dima, I believe I saw your hand raised.
Yes, I just want to add a comment here for this chapter, that you don't assume that other teams will understand what you're doing if you don't speak about it. So you must plan each steps and give information what you have done, so the other team will understand what are you doing.
Exactly. And I have a question for all of you. What is one way of understanding what the other team is doing, of becoming a little bit familiar with what the other team is doing? What's one way? We read a book about that.
Mob
Mob
programming.
programming. I mean, on one session, you can join the backend team and say, hey, I want to implement this particular feature with you guys. So that at very least I can understand what's going on there. You see, for example, let me give you an example. Where I used to work, we did mob programming a lot, okay? And we were you could say, the mobile team, Android and iOS, and we worked a lot. But every now and then, we would realize that there were bugs in the backend. And prior to doing mob programming, even with backend people, we realized, okay, we have to open a ticket. We need to let these people know that there's a problem, and now we are on the mercy of them so that they can fix the stuff. And yeah, we just have to wait. Some problems, of course, again, we're not experts on that system. So there were certain problems in which we depended on them. They know their system, they know what to do. Yeah. But we realized that there were certain scenarios in which the problem, I mean, it was, as an example, the wrong Boolean expression or the incomplete Boolean expression or whatever it could be. We don't need backend for that. So what did we realize? Every now and then, we will fix the problem in the backend. We will, of course, create a pull request and they will approve it. But the benefit of that is that since we felt comfortable enough, that's the keyword here, comfortable enough with that system, there were certain problems that affected us and we could fix it ourselves. They just approved it and we don't have to depend on anyone. You see, again, we wouldn't consider ourselves backend developers, but we understood a little bit what was going on there because that system depended on us. Or sorry, our system depended on them. So yeah, it was in our best interest. Any thoughts on that? So keep that in mind when you start working. Just don't. I mean, focus on your stuff, of course. Yeah, but don't become blind to the exterior. Also, at least be curious about those, and don't think that you need to be curious about everything. For example, I was never interested in web. I never joined those sessions. I'm not interested. I'm only interested when I need to build something, and when I need to build something that is web related, I say, do I have to build? Why do I have to build it in web? But anyways, I will find a way of dealing with it. But otherwise, it's not my stuff. I don't like it. So yeah, but you still need to become a little bit familiar with it. And all of you will have the same. All of you will have the core technology that you want to become good at, and but then you do need to learn a little bit of other stuff to complement. Any thoughts on that? Any thoughts on that? No? All right. This is a good one. Page 54. Don't just learn the language, understand its culture. Do you want to hear something funny? I know, based on the solutions that students write, I know if they have experience in another programming language. How do I know? Because they solve the solution, but they solve it in what I would call, that's not the Python way. For some reason, I see it a lot in the Python group, in the data group. I don't see it that much in the Kotlin group. Not sure why. What do I mean? The perfect example, the perfect, easiest example is where I see it over and over again with the for loop. In both Kotlin and Python, if I have a list, how do I do a for loop? Let's say it's a list of names. I say for name in names, and then I'm looping the actual elements on the list. Do we agree? But everyone here should agree, because that's how it works in Kotlin. That's how it works in Python. You have a list of names, and you just say for name in this collection, and then you start looping each element, right? Well, in other programming languages, say Java, C++, C#, I don't know now because I haven't used those languages in a long time, but back then, that's not how you looped a list. How did you loop a list? Well, you said, I'm going to loop from the number 0 all the way to the size of the list -1. So instead, I will go, I will go from 0, 1, 2, 3, 4, 5 as an example. And then to access the elements, I will have to use the accessor operator. Yes, that works in Kotlin. Yes, that works in Python. But why would you want to do it like that if you have this other way that you don't have to be as I say, you don't have to be manipulating indices? You can just get the item directly. So when I see that, I always ask, why did you decide to do it this way? Usually they don't know. They just said, this is how I loop. And I then follow, do you have experience in other programming languages? Usually the answer is yes. And if they say no, then I say, okay, then someone did the homework for you, because that's not even how I explain. I have never done a for loop like that. I don't teach it like that. So why would you do it like this? Makes no sense, unless you have experience or someone did it for you. Anyways, that is what it means with understand the culture. Probably you will hear these things as the Pythonic way or the Kotlin way. What does it mean? Each language has certain features, and there are certain things that, depending on the language, you would do one way, or you would do it in a different way if you were in a different language. So that's what it means, that it's not only about learning the syntax of the language, but knowing the features that the language has, so that you can really take the most out of the language by using those features. You see? Any thoughts on that? Any thoughts on that?
Yeah, it's like in Python, apparently they have index -2. You can call the -2 on the index. That's like, oh.
Well, like -1. So in Kotlin, exactly, that's a good example. In Kotlin, if I want to have the, let's say the last item might not be a good example, but the second to last item, I need to do it mathematically. I need to get what is the last index, and then from there, -1. In Python, you can do access operator -1, -2. So when you do negative, you're traversing the list from the other direction. That is another good example of a Pythonic way of going backwards in the list. In Kotlin, you have to do it in a different way, more mathematical. Exactly. Another example, Kotlin has null safety, the Elvis operator, for example. And a lot of students over rely on if statements. Too much if statements. Like, if it's not null, then assign result equals to 0. Hey, just write the thing in the Elvis using the Elvis operator, and that's it. You see, that's what I mean. Other languages, Python, for example, they don't have null safety, so they have no choice. They have to do the if blah 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 equals to none. But the Kotlin has that. So by learning that, the syntax and also the features that the syntax has, it gives you much more power when using it. So yeah, think about that. Think about that when you're learning a new language, the features. And if you're wondering, a language that I believe could be good for everyone to learn, I mean, there are many. I would say two. one is C#. C# is a very good language. The reason is because it's used in a lot of different contexts. Backend, for example, and there's a lot of jobs also in C#, backend development. And also I forgot now because I used this when I was in the university. It was a long time, but they had this feature of link or link queue that I don't remember, but it was something about the way of querying information. The language had a built-in query stuff. I don't really remember how it was, but it was very powerful. I do remember that. It was very powerful. So I recommend looking into C#. And probably we're looking into possibilities of offering a course in C# as well. We will see. But C#. And the second language that I recommend you guys learning, just because, not necessarily because you might be developing programs with it, but because it would change your way of thinking. And that is any functional programming language. Because in a functional programming language, it's a totally different paradigm compared to what we're using in this education, Kotlin and Python. A pure functional programming language forces you to do things that, or you cannot do things that you can do in this paradigm that we're using. So again, it helps you look at problems in a different perspective. And of course, that knowledge, you can then use it elsewhere. So if you are like looking for hobby projects, those will be two. And I will begin with the functional programming. Yeah.
What's functional paradigm? Is a language?
No.
Functional
programming is just a
like
programming. Yeah, like object-oriented programming. It's a paradigm. It's a paradigm.
Okay.
And then you need to find languages that support that paradigm.
Yes,
exactly.
Yeah.
And Haskell is one of those, I believe. And there are many others that I don't know. I don't think so. Maybe they have some functional programming features, but it's not a pure functional programming language.
Okay.
Kotlin, for example, they have functional programming features as well, but you can also do object-oriented. But if you go to a purely functional programming language, you have no choice other than using functional programming. So it will force you to think in a specific way. And again, it's not for you to become an expert in it. It's just to experience it and learn that perspective. Oh, wow, we're running out of time.
That takes the functional programming, it takes the short functions to like the extreme, like this is it. One short, nice, beautiful function.
Exactly.
And that's it. You don't change the data anywhere,
exactly.
But inside the function.
Correct.
It's not like, oh, I have a list. Oh, where I have the list. Oh, no. There you go. This is it.
So it helps you think in a very specific way, and then you can bring that knowledge back into, say, Kotlin or Python or whatever it is, so that you can then try to apply those knowledge. Good. Any thoughts on that? No?
That's good. So I'll take it and try to learn about it a little bit. Just one way to language
right now,
mentioned, yeah.
Sorry, right now, at least for Enrique and Murat, that you're in the education, I want you to focus in Kotlin and Android. Yes. Do not use your time for other stuff. Like focus on this. Once you're done, of course, go to other stuff.
I mean, watch a video to see like the overview of the paradigm just to.
Yeah, but
don't get into it. Don't get into it.
Yes, otherwise I need to put more work because Anyways, last minute. I would just say don't ignore that error. Any thoughts on that? I think you guys
just don't do it.
Yeah, I guess you guys now feel more comfortable with errors. You don't escape from them, but you read them. Hopefully you do. But yeah, I think this chapter was quite straightforward. Just don't ignore the errors, read about them, and try to solve them immediately.
And also use them if you can use
for
them.
debugging. Exactly. Good. Any more thoughts? Any questions? Any last comments?
This book is good. I like this book.
Yeah, it's very good book. I recommend it.
Put on the next one. Put something like this that is like short.
I will have to see what we have.
Like here you go. 10 recommendations. 90 recommendations.
Yeah. No, I mean it's. I will see. We still have a few more pages to go, so hopefully at least onto June we have good content or something like that. So we will see. Good, everyone. Thank you for joining. Thank you for
Yep.
today, and I will see you then either lecture or next week in the book circle. Okay.
Have a nice
Yes.
one.
Thank you.
Have a good one.
Bye-bye.
Bye. Bye.
Hey, do.
Bye-bye.
Bye.